Here's another counting problem. This time we're going to flip it. Mia is now volunteering at a weekend meal program, packing lunch boxes. On day 1, she packs 12 boxes. On day 2, 18. On day 3, 24. The pattern grows by 6 each day. After several days, the total number of lunch boxes packed is 210. The question is, how many days did the packing continue? Pause the video and try it. Don't add the days one by one. Look at the numbers. 12, 18, 24. What do they all have in common? See if that gives you an idea. Pause now. I'll wait. Let's look at idea 1. Every single number has something in common. 12, 18, 24, and the next ones too. What is the largest factor they all share? They are all multiples of 6. 12 is 6 times 2. 18 is 6 times 3. 24 is 6 times 4. So every day's count is a multiple of 6. That's our handle on the problem. Now idea 2. Here's the move. We will divide every day's count by 6. What does the pattern of numbers become? And what does the total of 210 become? We shrink the whole problem. The pattern becomes 2, 3, 4, and so on. The total becomes 210 divided by 6. That is 35. So the new question is simple. How many small numbers starting from 2 add up to 35? 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 equals 35. That is 7 numbers. And we can check it using Gauss pairing. That was the trick from our very first video and from the bookshelf video. 2 plus 8 is 10. 3 plus 7 is 10. 4 plus 6 is 10. The middle is 5. Every pair adds to 10. The same total, again. So the answer is 7 days. And here is the big lesson. 2 tricks work together today. First, scale the problem down by what every term shares. The big numbers shrink into small ones. Second, use Gauss pairing on the small numbers. The same trick we've used twice before. The more tricks you learn, the more you can combine. That's what makes you a strong problem solver. Learn, compete, and win. Visit competitivekids.org.